results are being received by managers, particularly when we're talking about invasive species monitoring and species at risk, whether the results are believed, essentially. And this is something I've thought about for some time, particularly when I was at a meeting probably about 4 years ago now, overhearing some managers essentially saying never again. They were never going to believe eDNA results again because they had they were I only overheard part of the conversation, but essentially that they were led to believe through eDNA results that northern snakehead were everywhere throughout their state. They spent hundreds of person hours electrofishing for northern snakehead, only to find out afterwards that the assay cross-reacted with smallmouth bass, and so that they were determined they weren't going to believe eDNA results again. And so I'm just wondering whether people are still sort of getting that sort of pushback, or whether with the proper validation and standards that we've been able to sort of overcome some of that.
Yeah, so it doesn't just happen with managers. I had a reviewer recently on a paper write that until I can explain every false negative in every assay, we should never use eDNA. To which the response was, find me any survey technique where you can explain every false negative in every assay. And I don't know how many other people are getting this, but it seems like DNA is held to a standard which no other technique has ever been held to. No one ever tells camera trap people to explain every false negative there is. I'm not sure why. And it came up, I was thinking about something that, I'm sorry, I've forgotten your name, with the frogs.
Danielle.
Yes. Thank you. You said at the end you'd rather go back to trapping, and then everybody got excited about trapping. But why? Why would you prefer trapping? Because it'll have a false negative rate as well. And I wondered at your comment about that, because it's a funny thing that I get lodged at me all the time. Well, until you can explain false negatives, don't do it. And I strike that as very odd, because I don't know anything else that has a false negative rate.
Okay.
False positives are a different thing, but false negatives.
Yes. So just to confirm, Beth, I understand your question. Why did I want to pursue a more traditional method over a molecular method for the Pacific water shrew on my project? Well, I would say my answer might have even changed slightly based on, no, I'm serious, that tube discussion or adding some sort of abrasion to the tube. I do value the integrity and vulnerability of that organism to more invasive methods. So just even with the collaboration in this room, I wouldn't say eDNA is out in this case, but the way I went about it, trying to sample the water, it was inconclusive whether that shrew was there or not. So we need to try, not necessarily not eDNA, but try it in a different way. I don't know if that probably didn't answer your question about absence.
It's sort of a question for everybody, which is this issue of how much validation are we going to do before people stop worrying as much about validation. Like this idea of a reviewer, a scientific reviewer paper, not regulatory, not legal, telling me that it's until I can explain every false negative, we should basically shut down the field of research. That's a researcher. That's not even a legal regulator. It's somebody who should know about error rates.
Sure.
It strikes me as very odd that we're being held to this, and I wonder what we do about it.
Yeah, great question, and one I think a lot of us in this room have given some thought to. I guess I'll add right now, at least in the US and at the state level, there are policies that do not allow us to use eDNA alone. So an example here in western states with zebra and quagga mussel, you cannot currently list a lake as being infested, let alone occupied by zebra quagga mussel based on molecular evidence alone. You do need that visual confirmation. Similarly, in Sebago Lake, Maine, a lake we just finished doing a project on, there's also policies in place that say you cannot apply the herbicide based on molecular detection alone. You have to have visual evidence. So that's one of the current barriers right now, is that there are actually, regulatory framework that does make us use eDNA as a smoke detector, as an initial tool to then direct further examination, but makes it quite hard to use it alone. And when we try to use it alone, or when we try to use it at all, we often spend a lot of our time doing this validation. In the States, again, we are starting to see a lot of movement by managers that are accepting the tool, but that are now stuck a bit more on the communication side of it. So I think they no longer doubt that eDNA is detecting DNA of the species. What they are struggling with is the communication of that, with a big focus on how we communicate what that may or may not mean. And so they're asking us to kind of clean up our act and come up with better decision support tools and communication tools to integrate that into their management framework. Another, supporting evidence of how folks are starting to use it in the States is that I'm a federal biologist, and the tool to date has been dominated by federal biologists and by university folks in the States. We're now starting to see a lot of states adding eDNA labs into their program. State of Washington, state of Oregon, and a handful of others are now building infrastructure internally to support eDNA, suggesting that they are starting to accept and use that tool. So I think there's a lot of strong evidence. It's shifting, and now we're on the decision support side.
I think that's really great, and I don't think most of us would ever argue that it should ever be the only tool in use. And I actually totally support the idea of a smoke detector type system, where it's a great survey to narrow in where to do more intensive work. I think it's how it should be used. But I'm quite interested in whether we're actually creating some of the problem with some claims about perfect detections and perfect things that create this expectation of perfection that no technique could ever get to. And I get more frustrated by telling people it's just a tool, who seem to think that we should be able to hear all false everything always. I find this a really interesting problem that no other survey technique ever gets held to. And maybe that's our fault, I don't know.
Beth, I think it's your fault. Now that you've shown movement by air, no one's ever going to believe any eDNA detection again.
I told you my motor problem, I'll talk about that in the break. Okay? Motors on pumps are an issue now. I think we should all be aware of this. It's weird that we're getting this, even in the scientific community. But I get these reviewers who write back and say, no error is allowed anywhere. True negative,
Yeah, I think we start probably running into the false positive issue much more than the false negative issue like you described. I think part of that's just, from the very get-go, as the technique was emerging, people kind of saw that as, oh goodness gracious, there's going to be DNA in the water, it's going to be throughout the water column, and you can have, be able to detect something, like a single frog in a lake kind of scenario. And I think just as we continue to communicate the realities of eDNA and sort of the limitations and capabilities of it, and it's just a matter of time, hopefully.
I trust you've seen John Darling's paper about why we need to stop worrying about. I'll have to share that paper with you. You wrote a great paper a couple of years ago, talking about a handful of virtues of eDNA and really kind of philosophizing about how we do actually need to kind of stop worrying and move on and get on with it and use the tool.
Yeah, I was even just thinking, because when we're talking about false negative, it really is, we do not detect signal either traditionally or via eDNA, while there is organism present in the habitat. And then it comes down to density. And of course, like SAR, species risk, they would always be very low density, or they're very elusive, they're very hard to tell. Then that got me thinking is, well, for those kind of species, how much do you have to actually put effort to detect? And if you were to put the same effort in eDNA, has anyone do a more comprehensive cost analysis?
You want to take that? I mean, there are a handful of papers out there. The one that comes to mind is Taylor Wilcox, 2016, that really did look at eDNA sampling relative to backpack electroshocking, and did put forth that cost analysis about money and effort for a 95% probability of detection. And it was quite obvious, what we would expect, but it was the first that I can think of that actually came out with that information.
I think more of that kind of information in trade journals and things like that would also help a lot with managers as opposed to just in the scientific literature.
Yep, so really focusing on that added value.
It's okay.
Yeah.
That's something that I'm actually hearing a lot in my conversations when it comes to standardization and the acceptance of this tool is people want to see that cost-benefit analysis. They want to see it more than just this one species. They want to see that discussion over a broad range of species. There are those single studies out there that I've found, but I've never seen anything that justifies the benefit of eDNA as a whole versus species by species study. So that's a task to some of you that if there is a way to do that, that would really help move the technology forward.
Yeah, and I'll just say, that this is something too that I think that, and part of the concern, with maybe managers being a little bit averse to it, is that perhaps some of us oversold eDNA at the beginning, and then I hear often how easy it is and cost effective it is to do the sampling, but don't necessarily include all of the downstream costs. And I think that, when you do factor everything in under a lot of circumstances, it still is cost effective, but there's a lot of hand waving without any specifics. And part of the GenFish project that I'm involved in with Bob and others, we have an economist on the team, and part of what we're doing is that cost benefit analysis, because that general hand waving doesn't really do enough to really look at that.
Thank you. I had a question for Adam, and then a comment on the topic of the false negative detection. So, if you accept that you have a false negative detection, you're also accepting that the environment has the target. It has to be. But if, by definition, eDNA assays are epidemiologically imperfect tests. So you need to assess them as imperfect tests to begin with. So the considerations around perfect testing using DNA shouldn't be a topic that should be promoted, in my opinion. Sampling effort is what improves false negative detection. And in that context, there's a researcher from Australia called Dr. Lee Sperlin. She made a formal essay on what happens as the abundance of fish species drops in a given environment. And what she demonstrated empirically is that as it drops, let's say you started with 1,000 fish, right? And now we're trying to capture 1 fish from that environment. The amount of samples we need to collect to assess sampling effort exponentially increases. So we go from 50 samples all the way up to 10,000 samples in certain cases. And in that context, you need to understand the cost of efficiency, right? Like if you need to collect 10,000 samples, well, that's probably not going to be the most effective one. And then my question, right? So with your sampler, have you considered, in the context of scale and volume of samples that would be collected by these machines, how are you, what receptacle are you putting the sample in? Are you using a heavily standardized little tube, or are you using a plastic bag to keep the sample, or a 5mm tube? And I ask this because you mentioned that you want to approach a space where eDNA detection resembles biomedical sciences and how we run diagnostics for human health. The only reason why we can take a blood sample today and get a result tomorrow is because the whole system has been automated. And the tubes that we use for sample collection are standardized across the board. I feel that that is the crux of how you would be able to improve detection, scalability of how many samples could be collected and processed by this facility. So is your automated machine considering that concept of how do we standardize how samples are being taken to the lab, and then what can be done in the lab to test that assay?
Parts of it. So we recognize that if we are successful and robotic sampling takes off, then all of a sudden we've taken the bottleneck that is in the field with technicians sitting there listening to our peristaltic pump for hours, and now we've taken that bottleneck to the lab. We are not attempting to do the in situ analysis right now. There's other great folks that are solving that problem, like John Hopkins is making some great headway there. but we are trying to hit this 3 to 5 year target for the machine, and it's just not doable with where we're at for in situ analysis. So what we're trying to do to, streamline or optimize the workflow is a heavy focus on the QA/QC. So these filters, after they are collect their sample in the robot, each one of them is stored in what's called a puck, a plastic housing. And we are now going to be attaching RFID chips that actually collect that metadata associated with that puck sample. And then that makes it that much easier for when the lab receives it to then just scan that in and with all of the applicable metadata. So we're minimizing that somewhat. We could try to figure out how to do DNA extraction internally, but that's just one more thing to go wrong in the field. And I think part of the scalability and part of moving from R&D to operations is that keep it simple, stupid concept. And if we really want to have success at scalability and broad implementation, I think PISCeS is what we've learned is critical across all aspects. So yeah, hopefully at some point soon in the future, but right now it's just more the KISS and focus on the QA/QC. And one more comment about the cost benefit. In that recent paper by Ryan Kelly towards the national framework, I think one thing that sticks out to me in the introduction there is the authors cite the cost of what it takes to charter a boat, I think in the Great Lakes, to do a fishery survey, upwards of $70,000 a day. Right, and so that's the cost of a lot of our traditional tools, and how much eDNA information can we get? And whether that's a half a day or just one day versus these fishery surveys that have to go out for weeks at a time at $70K a pop.
On the topic of the cost-benefit analysis as well, one thing that I wanted to bring up that I was also finding in some of the other novel detections I was getting in eDNA is they weren't necessarily comparable to electrofishing because they were in locations where it's either very difficult or impossible to do electrofishing, such as in deep repositories above dams where you can't actually do backpack electrofishing. So it's kind of hard to balance a cost-benefit analysis when it's kind of like comparing apples to oranges, where in some cases eDNA can access these points where electrofishing can, and then that makes the whole comparison a little more convoluted. And well, what exactly is the cost-benefit between the two methods when they may not access the same regions?
Thinking about scale, you're talking about scale a lot, and if anyone is interested in scale, Jeffrey West's book Scale, it's gigantic, but it's really, really good, and I know many of you out there have read it. And I was excited to see your EDIT model, that you're using that for streams, and that's about where DNA deposits in the landscape, and how deposition, we just did an analysis on disturbance, how disturbance changed the scale of eDNA signal that you get, reflecting the environment. I'm curious to hear from you guys if you've thought about the scale of time and space that varies when you're collecting your samples, and how maybe we can use AI or models or data integration to improve our answers.
Do you want it, or?
You can you go first.
I guess one thing that this kind of goes back to the question that Matthew Yates asked me about looking at abundance, and how I was having some issues on the typical analytical approaches weren't really working for me because my data just has a very large spatial and temporal side to it. So I have started to think about not just for abundance, but also the impact of covariates, detection probability, determining a best time to sample, because ideally I wouldn't need to do the summer, fall, winter sampling. I could just pick a optimal time and do 1 to 2 hits there. But sort of my traditional statistical techniques I learned in undergrad aren't exactly bringing me clear answers on that. So I'd be interested in further exploring potential ways of, especially with a large data set, that patterns can be derived and inform sampling decisions.
I guess the way we are considering it right now with the robotic sampling, one key thing with the robotic sampling is you get one sample at a time, but you can sample many times. So we're trying to take advantage of that time series information to better understand, for the most part, like temporal autocorrelation of the data. So, how far apart, if we're trying to optimize sampling and we only have 144 samples to fire off, how far apart should those be in time to really maximize our coverage, whether it's for an individual species or if we're doing a metabarcode coding approach. My postdoc Devin will be talking a bit about that some more tomorrow, about how do we think about sample timing when you only get one sample, but it can be spread across time. And so we're trying to take that idea of that temporal correlation and actually integrate some of that understanding into that EDIF model context. And also bring in a bit more of the occupancy, so the EDIF model currently is lacking any type of kind of false negative, false positive insight when it's trying to describe eDNA fading transport. And so we're adding that modeling framework onto the EDIF model. So that's a bit more of the space and time component as well. But I think that's a huge hurdle. And that's one of the things we're really excited about with the robotic sampling is that now we have the potential for awesome time series. And how do we use that time series information to better inform likelihoods of true presences, false negatives, false positives, all of those things. And so we can really track trend in the signal and the concentration over time. And then hopefully with a lot of robots that are somewhat intelligently spread out over space, we can look at how that maps and how information from one robot informs the other robots.
So I'm not sure, because myself is not a molecular biologist. That's really not my background. And when I was thinking back, courses I took in my undergrad, wildlife conservation and management, things that use traditional data, collars, GPS collars, and people in that field, they use a lot more spatially explicit models, movement models, different things to kind of help them understand the data they have. So I almost feel like, at least in this conference, and of course I haven't had a chance to talk to most people, but it feels like there is a knowledge gap where we have bioinformatician, we have molecular biologists, we have people that knows everything on the molecular side. They can give you data, they can tell you taxonomic information, but how that actually correlates to spatial and geographic information and how that actually being used statistically, I feel like there's a gap there. So like we need to maybe expand eDNA or invite, wildlife biologists that come in or a statistician to help us build that gap, to help us, identify the false negative, maybe have posterior possibilities or something. So maybe there's more room for collaboration.
I would say, just collaboration is probably the most important thing for that. No one's going to be an expert at all steps of the process. There'll always be need for consulting for different parts of any research project like that, I think.
I'd say that the eDNA field is a bunch of robbers and thieves. That's all we've done is taken ideas from other fields, whether that's occupancy modeling from wildlife. I mean, occupancy modeling is what a lot of us use here to assign livelihoods. That's something that is from population ecology. Or if it's ideas about standards, we're taking a lot of that information from the forensics fields or the non-invasive genetics fields. Microbial aquatic eDNA, we took that from the microbiologists. So I think a lot of this discipline is really being built from other disciplines, and there's a lot of us, like I'm a fisheries biologist, I'm not a geneticist, and so I think a lot of us are figuring out how to appropriately use this tool and integrate knowledge from a lot of other disciplines. I'd say at the U.S. Geological Survey, the agency I work with, we intentionally work right next to hydrologists because we recognize that so much of the insight we need about eDNA is all about this eDNA fading transport. How does it move? How long does it last? There's people that have been studying that question for decades, with other systems, and so we are taking their knowledge and trying to figure out how to integrate it into our field. So I think it's happening. Maybe it's not obvious, but it's definitely happening and occurring, and I think we're always excited to learn more and more from other fields.
Just a lot of talk earlier about CDAs and now about collaboration, so we're kicking myself if I didn't make a plug. So the iTrack DNA project is also putting together a CDA directly comparing eDNA costs versus traditional sampling. We're very much looking for participants. So if you see me or Karen walking around the poster session, we'd love to get more input. Really, we're looking for studies where you apply both eDNA and traditional sampling methods and then comparing detection rates for both. So, yeah.
Okay, it looks like, unless I'm missing any hands, it looks like there are no more questions. Yeah, so I just want to thank all of the speakers for this session, and of course thank all of the conversation and discussion in the audience as well. That's the thing that's so nice about this meeting compared to some big meetings where there really is that opportunity for discussion, and hopefully that will continue as we go through this evening and tomorrow. I don't know if there were any announcements from the organizers. Oh, here, before class is dismissed.
Well, thanks again to our panel, to all of us speakers today, for all of you for the long slog, and it's not over yet. We have another reception, dinner, and posters. Sadly, that call that I just had to take was the driver who was bringing over the catered food, and it seems to be lost.
Oh no.
Hopefully I've gotten him to where he needs to be. But dinner will be sitting on plates waiting for us. We'll have to have a beer or two first. But I promise it will get here. So we'll head back to the Summerly Science Complex, and tomorrow we're back here at 8:30.